And I want to take the opportunity to thank our amazing sponsors, the Home Depot and Bank of America. So we appreciate your help and your sponsorship so much. So a big thank you to both of you. And now I'm going to introduce Kesha Williams, who is running the amazing workshop today. And Kesha is an AWS training architect at the Cloud Guru. And she's going to be running a workshop, 3 workshops. So this is the first one today, and there's going to be an amazing hackathon in August, which I will let Kesha talk about. But yes, now I'm going to pass over to Kesha.
Hello, everyone. Let me share my screen. And let me share my slide deck. So I'm hoping that you all can see my slides. If you can't, someone please let me know. So welcome.
I think we can see them, Kesha.
Okay, perfect. So I just want to welcome everyone to this Machine Learning for Social Good workshop series. My name is Kesha Williams. And this is the first of 3 workshops. Today we're going to talk about tools and techniques. In the second workshop, we'll talk about data prep and actually getting your data ready for the machine learning process. And then we'll talk about training. And this plan is really for the 3 workshops will prepare you for this hackathon. And so you're going to take everything that you've learned during the workshops to compete in this virtual machine learning hackathon. It's called Mission Predictable. And the first submission is due on August 14th, and the live judging is August 19th. And the overall goal is to use machine learning to battle COVID. And just to highlight, there are some amazing prizes. You should be really excited when you think about this. You'll get 1 year free access to a Cloud Guru, and that's the company that I work for. We have online cloud education to prepare you for the cloud and then help you become certified in all of the major cloud vendors like AWS, Google, and Microsoft Azure. And you'll also receive $5,000 in AWS credits to continue building out the machine learning application. So welcome to the first workshop. We'll look at machine learning techniques and tools. A few housekeeping items. In order to get the most out of this workshop series, I do recommend that you have prior coding experience. We will use the Python programming language. You don't have to be an expert at Python. I'm definitely not an expert. I have a Java background, but we will use Python, so I recommend having prior coding experience. You'll also need to have an AWS, Amazon Web Services, free tier account. And when you set up that account, it does require that you have a credit card. And also our friends at AWS, they are giving each person in the workshop $200 of AWS credits, and those credits will go a long way as you build out machine learning and explore it. I will be available to answer questions during this workshop series on the Women Who Code Slack group. And I've created a channel called ML Series where I will be able to, I'll be available to answer questions. And today I actually have a lot of information to cover in just 1 hour. So I may not have time for Q&A at the end, but if you join the Women Who Code Slack group and then join this channel, I will monitor that channel and answer all of the questions that you have. And also, as we prepare for the hackathon, our friends at AWS, they are making their experts available to us through their AWS Machine Learning Community Slack group, and they've created a channel just for this workshop and hackathon, and it's called Event WWCode, and that's the channel. So definitely join those two Slack groups. Okay, so the machine learning techniques that we're going to talk about today, we're going to talk about supervised learning and unsupervised learning. And I will go in detail about what this term means. Going into this workshop series, I don't expect for you to have experience with machine learning. I don't expect for you to have experience with Amazon Web Services. And so today we'll look at 3 machine learning techniques using 3 real-world use cases. So we'll use binary classification, looking at a public safety model. We'll look at emotion detection, and we'll look at a movie recommendation engine. I'm really picking up where I left off from in my talk last week, Friday. And so I did a talk on machine learning for social good at the Connect Digital Conference. That talk is available online. So if you haven't seen it, I recommend that you go and watch it. It's on YouTube. And so a lot of what I covered in detail in that talk, I'm not going to repeat today because I have a lot to cover. But in that talk, I reviewed this machine learning life cycle. And at a very high level, when people start with machine learning, they're typically coming from a software development background. And so when you think about the software development life cycle, it is meant to produce an application. But when we look at this machine learning life cycle, it's meant to produce what's called a model. And so the high level steps in this life cycle are: first, you obtain data. So you find the data using a reputable source, and then you go through a process of preparing the data. So you have to get the data ready for the machine learning process, putting the data in a format that a machine can actually find trends and patterns, because that's all machine learning is. It's where a machine studies the data that you give it and it finds trends and patterns. And so later, once it's stored those trends and patterns, you can consult it and ask it questions. And I'll show you examples. So once you prepare your data, you go through this training process. So this is basically the teaching process. It's where you're teaching the machine by feeding it data. And so there is a learning algorithm that looks at the data, multiple iterations going through the data, and it produces what's called this model. And now once you have this model, think of the model like an application. You have this model, you're going to evaluate the model, and then you're going to productionize the model or deploy it and put it in a production environment where another system can actually use it. So think about this model like an app, and really it's just a mathematical representation of trends and patterns found in data. And once you have this model, you obtain what's called a prediction. So you ask the model a question. For example, you can have a model that's integrated into a banking app and it's able to detect fraud. Or you can have a model that's integrated into a recruiting application to find the ideal candidate. Or you can have a model that's used in the courthouse to predict if someone is going to be a repeat offender. So once you have this model, you essentially have to make it available so that it can be used. Today, the tool that we're going to use to produce this model is Amazon SageMaker. SageMaker is a service provided by AWS. And just think of it like machine learning as a service. Out of the box, it comes with Jupyter notebooks. If you're not familiar with Jupyter, think of it like an IDE for machine learning. It allows you to enter code and execute that code, and I'll show you an example. So that's a pretty popular tool in the machine learning space. Amazon SageMaker also gives you access to powerful training instances, so GPUs. You'll have access to that. And all of those life cycle steps that I just showed you in the previous slide, all of those fit under the SageMaker umbrella. So you can do all of those steps in one location. And with SageMaker, it also abstracts away a lot of the complexities surrounding machine learning, and it makes the process easier. And one feature that I really, really love about SageMaker, it has what's called automatic model tuning. And so essentially it runs different configurations trying to find the best performing model, and it gives that to you. So SageMaker is the main tool that we'll use. We have 3 case studies to review today. So there's a public safety case study, emotion detection, and movie recommendation. So let's start with the public safety. And this is the one that I briefly talked about in my talk last week, Friday. I love the movie Minority Report. And if you haven't seen it, you definitely have to watch it. It's science fiction, it is futuristic. And in that movie, there's this concept of pre-crime. And that is where a criminal is arrested right before they commit the crime. And so I wanted to use machine learning to bring pre-crime to life. So let's take a look at this example. So essentially, once you have this crime predicting model, you're asking the question, is crime likely to occur given these data points? And the machine or the model will respond with either yes or no. So anytime you want to receive a yes or no answer from a machine, you're using what's called binary classification. So binary, 1 or 0, 1 is yes, 0 is no. And it's called we're using supervised learning because we're using labeled data. So during the training process, we feed the machine labeled data, and I'll show you an example. And so it's data that has both positive and negative crime records. So we're saying this row or this observation indicates crime, this row or this observation doesn't indicate crime. And so the machine studies that data, finding trends and patterns, and it learns, and so it's able to answer your question, is crime likely to occur? Okay, so for this use case, the tools, we'll use Amazon SageMaker, Jupyter Hosted Notebook, and like I said, that's an IDE for machine learning. And remember I told you during the training process, there's a learning algorithm that reviews or analyzes the data. Out of the box, SageMaker comes with a ton of learning algorithms that you can use. In this case, we're going to use what's called the linear learner learning algorithm, and you essentially pick the learning algorithm based on the answer you want back from the machine. So in this case, I want a yes or no answer, and so that's why I'm using the linear learner. We'll also make use of Python data science libraries. Pandas, it has data frames and it allows you to work with and manipulate data. Matplotlib, that is a charting and data visualization tool. And then we'll use Amazon S3. If you've never used S3 before, think of S3 as a file or object store in the cloud. You essentially just load your data, like your files, to S3, and they're called buckets. So you load your data to an S3 bucket. So instead of calling it a folder, you call it a bucket. So let's look at the data for this use case. Now, all of the examples that I'm going to go over today, I've loaded in this public GitLab repo. So I've included the data and the Jupyter Notebook. So let me show you the before and after data. And when we think about machine learning, the data is key. So the data is the most important piece of this process, because if you feed the machine bad or biased data, and then the output that it produces is going to be bad or it's going to be biased. So just remember, garbage in, garbage out. So let me show you the before data for this crime use case. So I was able to pull data from the UK. Like I said in my talk last week, I searched all over the place and I could only find public data from the UK that shows stop and search records. So this is where a police officer stopped someone, recorded all of the details about that stop, about that person, and then recorded whether or not the stop led to an arrest. And so remember I told you when you have labeled data, in this case you have to show positive and negative records. So I'm presenting from two monitors, so I'm going to turn over now and look at my second monitor and walk you through what this data looks like. So here in column A, remember I told you binary classification. So this 1 indicates that this row is a crime record. And if I scroll down, I have thousands of records in this spreadsheet. In column A, you'll also see 0, which indicates that this record or this observation does not indicate crime. And so here this is the crime flag in column A. This is the location. This is the time of day. This is the day of the week, the month, the gender, and the age. So this is the initial data set. Now, when we talk about those learning algorithms, they can only understand numbers. And so a big part of the data prep step is taking this data and converting it to a format that a machine can learn from. So this is the before, and let me show you the after. So this is the after. And so I'll show you the code in the Python notebook that produces this final file. But if you notice, there are no more strings. Everything is represented as a number, and that's very important when you're dealing with machine learning. Okay. So now let's look at SageMaker, and this is what I did not show you last week in my talk, how to actually take a notebook that's in a public repo and load it to SageMaker. So when you want to follow along with me, you'll take the URL that's on this slide, and I'm going to copy that. And then you're going to go to your AWS account, so Amazon Web Services. The very first time that you log into AWS, you'll see a screen that looks like this. It's the management console, and it shows all of the services. So there are a ton of services provided by AWS. Now, the first thing that we have to do, we have to take the data file, that Excel CSV file that I just showed you, the original file, and we load it to an S3 bucket. And so you can type the name of the service here. And now this shows all of the S3 buckets in your account. You'll have to create a new bucket, and I'll just show you the one that I created already. And you could easily search your S3 buckets by using this field here. Okay, so I've created this bucket, and I've uploaded this crime data CSV file that we just looked at. And so now this file exists in the cloud, and it can be accessed by the SageMaker service. So we go back to the main page, and now let's pull up SageMaker. So just type SageMaker, click on it. And now this is the main dashboard for SageMaker. There's a lot that you can do here. But for this example, let me walk you through how you create or launch a Jupyter notebook. So you're going to take that notebook, the URL that I provided on that slide. You're going to come down to notebook instances, and you'll click on that. And then you'll come to a screen that lists all of your existing notebooks. And then you'll click on Create Notebook Instance. You'll give your instance a name. I'll just put something here. And then you're going to pick the instance type. Now this is very important because with the free tier account, there are only a few instance types, and I'll show you the full list, provided under the free tier. And as you continue to move up and go to the compute optimized using GPUs, some of those are not covered under the free tier and they can become really expensive. So I recommend just using the initial default provided there. And then you'll create what's called an IAM, Identity and Access Management role. Okay, so IAM is a service that allows you to secure your resources, and they make it very easy for you to create this new IAM role. And in basically what we're doing, we're just saying that SageMaker now has access to the data in that S3 bucket that we just created. So you would click create. I'm going to cancel because I've already created it. Now you can take the defaults for everything else except for under Git repos. This is the most important piece. So here, instead of none, you're going to do clone, and then you're going to paste that link from the slide. And then you'll do create notebook instance. Now I'm not going to create it because it's already created, but that's how you would pull in the Jupyter notebook from that public repo. And then once it's created, you'll see a screen that looks like this. And then you simply click on Open Jupyter. And when you open Jupyter, you'll see a screen like this. And then you'll select the notebook. And then you see all of the Python, the lovely Python code that I've added. Now, this is the use case that I covered last week. So I'll just go through this at a very high level. To find more detail, you can watch my talk. So here I'm just importing some of the data science libraries that I mentioned to you before, like Pandas, NumPy, SageMaker, Matplotlib. This data ingestion piece, this is the code to actually reach out to that S3 bucket and pull in the crime data. Here in cell 27, this is where I'm starting the data inspection and visualization. In my talk last week, I mentioned that whenever you're working with machine learning, as the engineer or the data scientist, it's very important for you to have domain knowledge of the data that you're working with, because it helps you detect anomalies or issues with the data. And like I said before, data is the most important piece of machine learning. So this is where I'm going through and inspecting the data and really understanding the data. And I made the joke last week, after creating this public safety model, I have like a really good understanding of what crime looks like in the UK. So if you're ever going to visit the UK on holiday or vacation, there are certain counties in the summer that you want to stay away from. So reach out to me and I'll tell you more about that. But here I'm just going through the process of inspecting and visualizing the data. I'm using Matplotlib to add in this chart. And here I'm just looking at the relationships between the different columns, trying to get an understanding. So for example, in Hampshire County, this 0 shows the number of rows or observations that don't indicate crime, and this shows the rows that do indicate crime. I'm also looking at it across gender. And then typically whenever you have data, you'll have issues with the data. You'll have data that has null or empty records. And so you definitely don't want to feed that to the machine during the training process. And so I'm just going through here and I'm removing null or empty records. And then remember that final training file I showed you that was all numbers. So this is the part where I'm going through and I'm doing this encoding and transformation process. So here in cell 35, I'm just listing out the data types. And you can see that there are several listed as object. So that means string. So those have to be converted. In cell 36, here I'm using what I call the find and replace method. So data points that can easily be translated to a number. So for example, in that data, whenever you see Tuesday, replace it with a 2. Or whenever you see March, replace it with a 3. So I did that for the day of the week and for the month. But what about those records that, or those fields that can't easily be translated to numbers? Well, there's a technique called one-hot encoding, and that's just a really cool technique. I like how it sounds. But essentially, you use that for values that can't be easily translated. So for example, gender. So gender has two, let me show you here, has two distinct values in our data set, male and female. And so the way this works, you take this gender column and you break it out here based on the distinct values. So now in the data, I'm going to have a column for gender female and a column for gender male. And then I'm going to put a 1 to indicate what that row represents. So for example, row 0 here represents a male, and down here, row 3 represents female. And so I need to do that for all of the columns, so county and day of week. And so I do that, and I end up with this final training data here. And that was the second Excel CSV file that I showed you. And then you take that data, you split it into training, validation, and test sets. You upload it to S3, and then this is the process where you actually kick off the training process, where there's a learning algorithm that goes out to the S3 data and studies it and tries to find trends and patterns. And that's what this code is doing here. And then the key here is the binary classifier. So I'm going to skip down to setting up the hosting. So once you have this model that's produced through training, with SageMaker, you can actually host that model through an API endpoint. And that is super cool. So now any application that can make an HTTP call can call out to this model, send in the data, and then get a response back. So for example, here in line cell 50, this is what's called an inference. This is where you actually call out to the model that you've produced to get a response back. And so the data that we're sending in, if you recognize this, it's going to be like the day of the week, all those fields, age, gender, location, time of day, etc. So you send that to the model, and then the model sends you back this prediction. And if you see here, it sends back a probability score and then its prediction. So in this case, when I send in that data, it's coming back with the answer of 1, meaning yes, this indicates crime, and it's saying I am 99% sure that crime is likely to occur. So that is a quick look at the public safety model. Now let's talk about the emotion detection. Now, this is a model I created to detect the emotions of my kids. They are always my test subjects in everything that I do. I actually have 3 kids. So what did I do? I use this AWS Deep Lens, if you can see it. It's a camera, and it connects to your AWS account. And so you can take pictures with this camera and upload it to an S3 bucket. And so I set up this camera to send me an alert when my daughter came home from school, and it would alert me, letting me know if she was happy, sad, or angry. And if for that day, if she was sad, I would surprise her with her favorite treat, which is a milkshake from Chick-fil-A. So let's look at this emotion detection model. So the machine learning techniques for this multi-class classification. So this is where the machine can actually predict one of many. So for example, I send in an image to the model that we've created and it returns back, oh, this person is happy, angry, sad, or neutral. And this is another example of supervised learning because we're using labeled data, and I'll show you the data. The tools that I'll use for this, the Amazon SageMaker console. So in this case, I'm not using a Python-based Jupyter notebook. And so this is a great example that doesn't require coding at all. So if you don't have a coding background, you can still make use of machine learning through Amazon SageMaker. It makes it very easy, and I'll walk you through the process. The only tool that you'll really need is a text editor to create the configuration files, and I'll show you that. And so within the Amazon SageMaker console, remember I told you there are a ton of learning algorithms. In the previous example, we looked at linear learner. In this example, we're using what's called the image classification. And again, I'm going to store the data in S3. So let me show you the data. Okay. And this data I did not load to the public repo because I just don't want pictures of my daughter out there on the internet. So if you want to follow along with this example, you'll have to use your own pictures. But let me show you how I set it up. So there are 4 folders. In the first folder, I have pictures of my daughter angry. In the second folder, she's happy. In the third folder, she's neutral. In the fourth folder, she's sad. And I just wonder if she learned how to game the system. So when she came home, she would be sad and I'd just always bring her her Chick-fil-A milkshake. And then these are the 2 configuration files. So the training configuration file and the validation configuration file. So let me show you these files. And I'm just using a simple text editor to create these files, nothing fancy. And so what you're going to want to do, you're going to list out each image and classify it. So for example, here I have this happy one. I'm giving where it's located in the happy folder, and then I'm assigning this label. So notice this label. So all of the happy images I label with a 0. All of the sad images I label with a 1. All of the angry images I label with a 2. And all of the neutral images I label with a 3. So this is how the machine is going to learn. So now whenever I send, let's say, a happy image to the machine learning model, it's going to send back this label of 0, or 1 if it's sad, or 2 if it's angry. And so I've taken the data, I've split it up for training. So this lists all of the images that the machine learning model is going to learn from. And then there's validation. So during the training process, and we'll dive deep on the training process in workshop 3, but in this during the training process, the machine is going to have a set of data that it trains itself on, and then it's going to have a set of data that it evaluates itself on. So it already has the answer, and it's just going to basically test to make sure that it knows how to predict the emotion. So those are the configuration files. And so once you have your images and you have your configuration files, you'll go to SageMaker. So let me show you. So here, this is just an example of where I've loaded those configuration files as examples. So let's go to SageMaker. Now remember I told you in this example that there's no coding required. So all you need to do, and let me show you from this angle first. If you log into the AWS Management Console, you're going to go to the SageMaker service, and you'll see this main screen. Remember before we went to notebook instances. You're not going there this time. This time you're going to go under training and click on training job. So you'll want to create a training job. And this is just a previous training job that I created that actually worked. And so you have the option of cloning an existing job. It copies over all of the configuration settings. Now, the first time you go in, you're not going to have a job to clone, so I'll walk you through what you need to fill out. So when you create a training job, you're going to enter the name. And like before, you'll need this IAM role. You will create a new role, and essentially that's giving the machine access to the S3 bucket. And that's what I did not show you. Let me show you where I loaded the data. So just like the previous example, I created an S3 bucket. Emotion. I called it child emotion detection. Okay, so notice I loaded up the 2 training configuration files that we looked at. And then I have the folders. I basically replicated the folder structure that I showed you from my local machine, and I loaded up all of the images of my daughter. So with this IAM security role, you're giving SageMaker access to that folder. And then for algorithm source, remember I told you that SageMaker has a lot of built-in algorithms, so that's the one that we're using in this case. You can also bring your own algorithm. And then you choose the algorithm. So the learning algorithm in this case is image classification. And I'll just show you some of the other ones available. But in this case, you'd want to use image classification. You'd say, in this case, the input mode is file because you're passing in files. Then you would select your instance type. And then here you have control over the hyperparameter. So in my talk last week, I mentioned that a hyperparameter is nothing more than a configuration option that changes the settings for the actual training job. And so with SageMaker, these are the hyperparameters for the image classification. The most important ones here, most times you can take the default, because remember I mentioned to you that SageMaker has automatic model tuning or hyperparameter tuning. And so behind the scenes, it's going to change these options here and really try to find the best combination that produces the best quality model. And so that is a huge advantage of using SageMaker. But some of the parameters that you'd want to set. Here we have the epochs, or if you're in the UK, the epochs. And this basically says how many times the machine is going to review the data, trying to find trends and patterns. And then an optimizer. Within training, there's an optimization technique that really seeks to minimize errors. And I'll go through this in more detail in workshop 3. And then the most important piece is the number of classes, or the number of labels that the machine has to learn. So in this case, it's 4: angry, happy, sad, and neutral. And then you set up these training channels. Essentially, you are pointing this training job to the data stored in S3. Remember, I showed you the child emotion detection. That's all you're doing. So you're pointing it to the training data, and you're pointing it to, this is the validation channel, you're pointing it to that validation data. And then you're pointing it to the 2 training configuration files that I showed you. This is the training configuration file and the validation configuration file. And then down here, you're adding the output data path. So remember I told you that the training process produces a model. Well, this is where it's going to store the actual model artifact that's created. So I'm telling it to put it in this training output folder. And that's it. That is it. Then you click create training job. It goes off for maybe 15 to 20 minutes and it's training this model. It's evaluating the model, and then at the end of the process, you have this well-performing model that can now detect emotion. And like I mentioned to you before, once you have that model, you can host it via an HTTP endpoint, and then any application that can make an HTTP call can call out to the model, pass in an image, and get that label back. It's really cool. So that's a great example of using machine learning without having to code. Okay, so now the last example is this movie recommendation. So I wanted to play around and reproduce how Netflix recommends movies. So I created this movie recommendation engine using SageMaker. Now, this is an example of unsupervised learning. So in all of the previous examples, we actually fed the machine labeled data. So we told the machine from the crime prediction, like this row indicates crime, this row doesn't indicate crime. And with the emotion detection, we said, this is what a happy person looks like. This is what an angry person looks like. In this case, we are not giving the machine label data. We're just going to give the machine the data, and the learning algorithm is going to go through what's called clustering. So just think of a cluster as a group. So the machine is going to look at the data, try to find commonalities across the data, and then group the data into clusters. And so at a high level, the way the Netflix recommendation engine works, they've grouped, if you have Netflix, they've grouped you into this cluster. And so whenever you log in, they determine like which cluster are you a part of, and then your recommended movies based on people in that cluster. And so this example follows that same model. And so in this case, we're going to use SageMaker. We're back with code, so we're going to use the Jupyter hosted notebook. Now in this example, I'm introducing scikit-learn, which is a very popular machine learning library for Python. And it features various classification, clustering, regression, learning algorithms. And for this case, we're using k-means. So the k-means learning algorithm, it groups the data or observation in k number of groups or k number of clusters. That's why it's called k-means. Again, we're going to use pandas, matplotlib, and numpy, and that's a pretty popular data science library for working with multi-dimensional arrays. So let's look at the data, and this just shows where I've loaded the data in GitLab. So there are two data files. The first is a list of movies. So here you see all of the movies. Each movie has a unique ID. It has a name, and then it has a category. So for all of the movies, they're categorized. So it's sci-fi, is it action, is it martial arts, or is it adventure, comedy, kids? So all of the movies are categorized. So that's the first file, movies. And then ratings, this is the progress. So for this person ID 61, for movie 72, movie ID 72, they've watched 11% of this movie, and this is the last date they watched it. And so there are thousands of records for a given person ID. It shows all of the movies they watched and their progression. So that's the original data. So for SageMaker, you'll follow that same process that I showed you to spin up a notebook instance. You'll copy this link and just follow that same process again. I'm not going to demo that again, but I'll show you the notebook. Okay, so this is the notebook for the movie recommendation engine. Similar to before, I'm importing the data science libraries. And then here I am ingesting the data. So basically reading the data. And what's different with this process, you notice I didn't talk about S3. So in this case, the data is not loaded to S3, it's just loaded in this Jupyter notebook. So if I go back to this Jupyter notebook, there is a data folder and I loaded those two CSV files there that I just showed you. So it's just another option, another way to import data. And so here in cell 2, I'm reading in the movies data, and then I'm just printing out the first few records just to make sure it's right. And then I'm loading it into this pandas data frame, and I'm printing the shape. So the data frame, think of it like a two-dimensional array. And this first 75 shows how many records, so how many movies. And then this 3 shows how many columns represent that movie. So 3 because it's a movie ID, name, and categories. So next, I'm just printing out the categories. I'm splitting the categories, and then I'm actually getting rid, in cell 6, I'm getting rid of the name. And you'll have to do that often in machine learning. Like there are some fields that will not help the machine learn. So in this case, the machine doesn't really need to know the name of the movie in order to cluster users. It only needs the movie ID. So I delete the name and I'm left with the movie ID in the categories. Here I'm just verifying to make sure that there are no null or empty records, because if I did have that, I'd want to remove them. And now I'm reading here in cell 8, I'm reading in the ratings, that second file that I showed you. And I'm just printing the first few records. And now there are several cells of me inspecting and visualizing and understanding the data. Like I said before, whenever you're working with machine learning, you really have to have a good understanding of the data that you are working with. So this is showing the number of people that watched movie 73. So it shows here the person ID, their progress, and the last watch. Then I'm building what's called a cross-tabulation table. It basically shows the frequency with which certain groups of data appear in the data set. So for example, person 4 watched movie 2, movie 5, movie 6, movie 9, so on and so forth. And now I'm looking at the data types. So just like in that crime prediction example that I showed you, we have some string values that we need to convert to numeric values. In this case, progress and last watch. So I'm taking last watch and I'm converting it to a date time. And that shows, I'm showing you that here. It's now a date time instead of a string. And then I'm doing the same thing for progress. So here, progress is a string. I'm converting it to a floating point. And so I'm just double checking the data. Here, I'm counting the amount of times a person ID appears in the data set. That just helps me understand who watches the most movies. So person 4 watched 33 movies, person 2 only watched 1, so maybe they don't like movies. And then here, I'm just looking at the data set for a particular person or a particular user. For example, person ID, it shows all of the movies they watched and the progression that they've made. And then I'm counting the amount of times a movie appears in the data set. So movie 3 has been watched 10 times, so it's kind of popular. And then here I'm just printing the records for movie ID 5. Again, just really trying to get a good understanding of the data. And now this starts the process of actually getting that data ready for the machine learning process. I have 2 helper functions in cells 26 and 27. Here, I'm going through and calculating the average watch time per person across the different categories. So for example, once the code runs, I'll have a data frame that shows for each person ID their average watch time across the categories. So for example, person ID 3, they watched all of the science fiction movies at a 99% rate. Action, 98%. Kids, 74%. Like this horror movie, NAN, not a number, it basically means they didn't watch any horror movies. Maybe they don't like scary movies, so they didn't watch any horror movies. And so I do that for each person, for each category. And so this is starting to look like data that a machine can actually learn from. And so the next step is to get rid of these NANs. And so essentially what I'm doing, I'm converting those to zeros, and that's what it shows here. So up here, 263 is NAN, down here it's a 0. So now everything is numeric. The machine can actually take this and find trends and patterns. Here I'm dropping the person ID because that doesn't help the machine with grouping and clustering. And then I'm taking that final data set and turning it into a list. That's what I'm showing you here in cell 35. Okay, so I've done a lot of work to get this data ready. And now in cell 37, I am using scikit-learn, and I'm using the k-means learning algorithm. Here I'm defining 20. So I'm saying take this data, group it into 20 clusters. And then I run this fit predict function that kicks off the training process where the machine studies the data. And at the end of that process, I have for each person the cluster they belong to. Now that I have that cluster, I can make certain decisions based on that. So let me show you. So here I'm just taking that data and I'm putting it in a data frame, and I'm giving it a column called assign cluster. And then I'm doing some code logic here to determine the person ID and the cluster they are assigned to. And then I'm just counting the amount of times a cluster appears in the data set. So for example, cluster 11 appears 51 times. So there are a lot of people assigned to cluster 11. I'm doing some plotting here with matplotlib, but let me get you down to the most important piece. So understanding clusters. So you have these clusters. You know that a person belongs to cluster 6, but how can that really help you recommend movies? And so here I start the process of trying to find what's common across the people in cluster 6. So let me jump you down. Okay, so here. So what I'm doing, once I have the data and I have the people assigned to the cluster, I'm making a decision to only limit it to movies where people watched over 90%. So in this case, I'm assuming if a person watched less than 90% of a movie, maybe they didn't like it. And so I'm excluding those records. So finally, for each person, I have only the records where they've almost completed a movie. And that's across cluster 6. And then I'm getting the movie categories for that cluster. So what are the categories associated with cluster 6 greater than 90% watch? And those categories are sci-fi, kids, TV, epic, sports, and Western. So out of 24 categories, only 6 categories made it to cluster 6. And so the final result is when a person logs in to watch a movie, you retrieve that person ID, you determine the cluster they are in, you determine the categories liked by that cluster, and then you can recommend a movie based on those categories. So that was my first attempt at doing a movie recommendation like Netflix. I'm sure the Netflix recommendation engine is way more complicated than that, but this is a good start. Okay. So today we've looked at just some of the different machine learning techniques. So emotion detection uses a computer vision model because it's images. Public safety answers yes, no. The movie recommendation clusters and groups data. And so when we think about machine learning use cases to battle COVID, I've listed some of the ideas here. So for example, you have a computer vision model to determine if people are social distancing. You have a machine learning model to predict if someone will catch COVID when they are exposed to it. You have a machine learning model to predict patient outcome and recovery, and that's like a yes, no. Will they survive or not? You have the machine learning model that can project the spread. You can have a computer vision model similar to the emotion detection model to determine if it's regular versus COVID-19 pneumonia. And you can also have models to predict hospital capacity. So I've started this thread in the Slack group for us to just brainstorm together the different ways that we can use machine learning to battle COVID. So I taught you today 3 different techniques. So just think about the techniques that I showed you today and how we can apply them to use cases to help us battle COVID. As far as data sets, this is what we'll talk about in our next workshop. I was able to track down some of these data sets online. So we have access to patient level data in Brazil. We have access to images of COVID-19 pneumonia. We have access to COVID data by race. We have access to hospital capacity data. We have access to number of cases and deaths over time. So there are a lot of data sets out there, and I will go through those data sets, and we'll, in our next workshop, we'll look specifically at those data sets, and we'll talk about how we can use some of the machine learning techniques that we looked at today to battle COVID, and that is on July 8th. And as I wrap up, of course, I'm going to give you homework. It wouldn't be a workshop if I didn't give you homework. So I know I covered a lot today, and if you could go back on your own and learn more about some of the learning algorithms that I taught you today, the linear learner, remember that was provided by AWS Amazon SageMaker, and it predicts that binary yes/no answer. Then there's image classification. Go back and read more about the image classification learning algorithm through SageMaker. In the last example, I showed you scikit-learn and that machine learning library using k-means. We looked at pandas, we looked at matplotlib, and we looked at NumPy. So I've included those links there for you to go and read on your own. And then I will see you on July 8th, and that's where we get into the data. And so I'm going, and that's my presentation. I'm going to stop sharing. I know we are about 4 minutes over time. I do have time to hang out and answer any questions. that people have. And then also, like I said, there's the Slack channel where I will monitor that and also answer questions that I'm not able to get to today.
Thank
So
you so much. It's been really great today.
I know it was a lot.
Oh no, but it's amazing. Chat is on fire. The questions are on fire. The machine learning channel's going, and I'm really excited to work together with everyone this summer.
Me
Leading
too.
up to the hackathon.
Me
I
too.
think it's a great group. So thank you so much for sharing. We
My
do have
pleasure.
a variety of questions. Some of them you might cover in the Slack. Some of them are as simple as, what was the movie name you were talking about near the beginning of the webinar?
Minority Report with Tom Cruise. I've seen that movie maybe 30 times, and it's just really super cool because it came out, I think, back in 1991, and a lot of the technology that is shown in that movie is here today. And I'm like, wow, did the movie inspire the technology, or did the technology inspire the movie? So yeah, Minority Report with Tom Cruise. Check it out.
Thank you for answering that. A couple of the questions are a little more technical. One of them was going back to the gender piece. Why can't it just be a column with 0 equals female and 1 equals male?
That's a great question. As a part of the way that works with machine learning, if you do it that way, the machine is not going to learn correctly. And so it makes more sense to use the one-hot encoding. We don't want it to unnecessarily weight that field. And so that's why.
Thanks. And just one more practical mechanical piece. Would a Google Colab notebook work as well as the Jupyter notebook?
I am not familiar with Google. I am an AWS person, sorry. But I have, like, it's a Python, the Jupyter notebook, it's loaded into GitLab at that link. So that's a good question. I don't know anything about Google. I'm sorry.
Fair. I just want to be fair because folks have all these questions and they've just been like hanging on to it. Yeah, beyond that, I think we can kind of meet you in the Slack channel. So that is in our Women Who Code Data Science Slack, and we've set up the Machine Learning for Social Good channel in there. Sapphire
Yes.
shared that link a couple of times. Following this webinar in the next few days, we're going to send an email around to the participants and just let you know sort of where the links were, what's going on, when the next webinar is, because it's 3 webinars with ML for Social Good. This is the first one, and then the next one is July 8th, yeah, and then July 15th. We'll send you around an email about that. I'm just going to share my screen for 1 minute for a couple of other things. Share my screen. And we'll head out of here shortly, but the link here, which we'll also send round, this is at womenwhocode.com/mission-predictable-hackathon. That's where you're going to be able to register for the hackathon, learn more about those free AWS credits, and we'll be sure to send that link around to you too, because I know it's on your screen right now and that can be a little challenging. The next thing we've got going on in data science, we have another exciting webinar tomorrow, and that is all about solving e-commerce challenges with visual AI. That's going to be another great dive into technology. And this summer we'll be kicking off an introduction to NLP, natural language processing. That's going to take place throughout July and August. And you can find all the information about all of the things all of the time. Social media, we've got our Twitter, we've got Facebook, we've got Insta. You can reach us in Slack, you can email us. I mean, please reach out, send us kitten cards, I don't know. I mean, we want to share technical knowledge as well, but it'd be good to hear from you. And we just want to thank everyone so much. I know we're a couple minutes over the time. I hope you have a great day. And if you do have more technical questions, come find us in the data science Slack with the Machine Learning for Social Good channel. Kesha will be there, not 24/7, but she'll be around. Thanks, everyone.
Thank you.